Alright, today guys we're going to be working on section 5.0. If you go under Canvas to modules and pull up today's date, you can find the notes for this. We're going to be working on simplifying radicals. We're going to simplify the radical expressions. We're going to add them, subtract them, multiply, and divide them. So on the worksheet we have the examples up at the top, and then down here at the bottom we've got some that you are going to try on your own. There's some on the front and some on the back. So I know that in some of your Algebra 1 classes you guys learned about simplifying radicals, but other people did not. So it's probably about 50-50 based on what I got, the feedback I got from my other class. So I want to make sure you understand how to first of all simplify radicals. One common mistake I see when people are adding radicals is they just add the numbers in front and they add the numbers inside. Some people would say this would be 5 radical 68. Completely wrong, okay? You cannot just add the numbers in front and the numbers under the radical. In order to add or subtract radicals, you have to have like radicals. So in other words, the numbers under the radical have to be the same. That's the only way we can add. So I'm going to have to simplify this radical 50. So you should know some perfect square roots, like you know the square root of 4 is 2, square root of 9 is 3, square root of 16 is 4. These are all things that you have worked on before. These are our perfect squares. So one way to simplify a radical is to find the largest perfect square that can be divided evenly into the number under the radical. So if I've got 50, 36 does not divide evenly into 50. Does 25 divide evenly into 50? So I'm going to write this as 2 radical, and 50 I'm going to call 25 times 2. Well, the square root of 25 we know. The square root of 25 is 5. So when I do this then, I keep the 2 on the outside. The square root of 25 is 5, and we can't take the square root of 2. So we just have to leave it as the square root of 2. All right, so I broke up the 50 into 25 times 2. The square root of 25 was 5. There was already a 2 out there. That 2 had to stay because there is no radical for that. So another name for 2 radical 50 is 10 radical 2. Guys, if this is on the calculator part of a test, you don't need to get out your calculator, but just watch how I can check this. I want to know, is 2 radical 50, is that the same thing as 10 radical 2? Are they equivalent? And you can see that they are equivalent, right? So that's how I can check to see if I simplified that radical correctly, and we did. All right, now another way to do this though is to break the number that's under the radical down into its prime factorization. So I'm going to do this part another way, this part of the radical. So I'm thinking, what are the prime factors of 18? Well, I know 18 is 9 times 2, so I could just do this the way I did the other one. I could write it as 9 times 2. But I also know that 9 is 3 times 3. Isn't 3 times 3 times 2 the same thing as 18? Yeah. So I'm breaking this down into its prime factorization. As soon as I have, this is the square root, so as soon as I have 2 factors that are the same, I can take it out. I have 2 factors that are the same, so I can take it out. So I already have a 3 out there. I'm going to take out that 3. When I have 2 3s, since that's really a 9, the square root of 9 is 3, that comes out, and then we have the 2 on the inside. And so now we're going to have 3 times 3 is 9 radical 2. Now we have like radicals. So now we can go ahead and add these 2. And when I add these 2, I get 19 radical 2. So see how I changed the coefficient. I add the numbers that are coefficients and the radical 2 stays the same. Any questions on that? All right, let's go to number 2. Subtracting. Same rule as adding. I cannot subtract these at this time because they are not like radicals. I have different numbers under there. So I can either use the prime factorization method, or I can look for the largest perfect square that divides evenly into this number. What do you guys think? Do you prefer the perfect square method or the prime factorization? Raise your hand if you prefer the perfect square method. Okay, what about the prime factorization method? Okay, so we're going to go ahead and go with the perfect square method. So the largest perfect square that will go into 12 is what? 4. So I'm going to rewrite 12 as 4 times 3. The square root of 4 is 2, so a 2 comes out. But I can't take the square root of 3, so it stays inside. So another name for this is 14 radical 3. If I'm not sure I did that right, I check it on my calculator and see if they're equivalent. All right, can anybody think ahead as to what 2 radical 27 would end up being?
18 radical 3.
18 radical 3? 6 radical 3? Which is it? 6 radical 3. Here's why. We have to break the 27 down into 9 times 3. We don't just take out the 9, we have to take out the square root of 9, which is 3. So that's going to be 2 times 3, a 3 stays in, minus 6 radical 3. And so what is this answer? Just 8? Is the answer just 8? No, what is it? 8 radical 3. We only combine the coefficients, the radical stays the same. All right, completely different problem now, multiplying. When we're multiplying, we multiply the parts that are alike. So this negative 4 and negative 2 are alike. When I multiply them, I get 8. The radical 5 and the radical 10 are alike. When I multiply them, I get radical 50. Well, radical 50 I can think of as 25 times 2. So if that's 25 times 2, what's the answer going to end up being? Good job. 40 radical 2. Do you guys see how she got that? You have a calculator, you finish a quiz early, you type this in, see what it is, type this in, see what it is. If they're equal, you did it right. All right. Let's go down to number 4. This is another multiplication problem. We multiply the parts that are alike. So in the coefficient, we're going to get negative 10. Now, I am going to do this one different. I don't think you guys are as familiar with fourth roots as you are square roots. Let's talk about some fourth roots. The fourth root of 16, that means what number times itself 4 times is going to give us 16? That's 2. Do you know the fourth root of what? That would give me 3. 81 is correct. The other one we use a lot is the fourth root of something that would give us 4. Some people are saying it. 126 is correct. If you're not sure about that, here's how you can check it on your calculator. We could just do 4 raised to the 4th power. Oh, 256. 256, not 126. Or, watch what else we can do, guys. Go under your math, go down here to this xth root, and I'm going to check what is the 4th root. Somebody was saying 126, and if I check that, that's not correct, is it? But watch what I'm going to do. Second enter to get that back, and now I'm going to change it to 256, and that is 4. Okay, so this should be 256. Okay, and then that's about it for the fourth roots that we use. Okay, so anyway, I could multiply these two together and then break it back up. But for fourth roots, I think it's easier to go down to the prime factorization. 9 is 3 times 3. 18 is 9 times 2. So what would that be then? 9 times 2 is 3 times 2, okay? So since I'm doing a fourth root, I have to have 4 of these guys to be able to take them out, okay? Sometimes it helps to think of it that way. Whatever our root is, we have to have that many factors to be able to go out of the radical. So Sometimes I explain it like going out of the house, you got to have 4 people to leave the house, if you think of it that way. So we have four of the 3s, so we're going to have negative 10 times 3, 4th root of just the 2 is left, so negative 30, 4th root of 2. All right? I think that's easier than doing 9 times 18, getting that number, and then breaking it down into 81 times 2. See what I'm saying? So here's the thing with math, guys. The more tools you have, the easier it's going to be. Sometimes use the prime factorization. Sometimes just go ahead and use the roots. All right, what about this one? What do you think we would do on a problem where we're dividing? Divide the parts that are alike, right? We divide this part. What do we get if we divide that part? Negative 7. These are both radicals, so we're going to divide those two. What do we get? Radical what? Radical 8. Is this completely simplified? Go ahead and do it and tell me what you get. You guys agree with negative 14 radical 2? Yes, because this is 4 times 2, or I can think of it as 2 times 2 times 2. I have to have a pair of 2's to go out of the house. We've got it, negative 14 radical 2. All right, last one here for an example is the cube root problem. We do it the same way. These parts are alike. We get negative 4. We divide these two parts. We have a cube root that we have to keep that cube root. 16 divided by 2 is 8. Let's talk about some perfect cube roots. Do you know the cube root of 8? 2. 2 times 2 times 2 is 8. Cube root of what to get 3? 27. Cube root of what to get 4? You got it. Another one that comes up quite a bit, cube root of 125, 5. Those are the most common cube roots. You might come across a few more, but those are the ones that are the most common. Now, I can do it this way. I can break this down into its prime factorization. 8 is 4 times 2. 4 is 2 times 2 times 2. How many people or things do I have to go out of the house? 3, because it's a cube root. We got 3 of them. They can go out. So it's negative 4 times 2, and that's just going to be negative 8. Again, if I wanted to check it, I can type that in, and you're going to see that they're going to be equivalent. Any questions? Okay, on a scale of 1 to 5, 5 being you feel pretty confident with this, 1 being you're completely confused, show me a number. All right, lots of 4s, lots of 5s. All right, so you're going to finish this, you're going to submit it on Canvas, okay? This is an assignment that you're going to submit on Canvas before 8 o'clock tomorrow morning.